Welcome to John Explains Subnetting. I'd call this an episode, but I'm not sure if I'm ever really going to do this enough to call them episodes, but just in case, this is episode 1. I really don't know if it's going to be a series. The only reason I'm doing this is because I have sat through some awful explanations of subnetting, including one recently that was so bad that I literally forgot how subnetting works while the explanation was happening. I have been a sysadmin for around 30 years. For me to forget how something works because the explanation is so bad, right. That's not the worst explanation of subnetting I've heard, sadly enough. So what I'm going to do here is I'm not going to talk about what a subnet mask is or how to calculate things or sitter and classes and all the rest of it. I'm going to explain subnetting as a concept so that anyone listening to this who has no clue about what subnetting is, even if you don't know how to make a subnet mask or build one, you'll at least understand what's going on when people talk about subnets. So what is subnetting? At its simplest, subnetting keeps everything from talking to everything else at once, where everything is computers on a network and where computers is anything able to get on a network. I don't want to get too pedantic about this, but this can include your refrigerator. That's the basic entire TLDR concept of subnetting and why it exists. It literally keeps everything from talking to everything else at once. This is required because of how modern networks work at a low level. Whether your network is wired or wireless, they broadcast. They are a broadcast network. A good way to think about this is like talking to someone at a party. You may only be talking to one person, but everyone around you can, in theory, hear what you're saying. Ethernet, which is the wired network you'll use pretty much all the time, or Wi-Fi, the wireless network you'll use pretty much all the time, are both broadcast networks. So even if you're sending a file directly from your computer to another computer that you are no more than a meter from, unless you have a cable hooked up directly to that computer or you've done some finagling with wireless so that you are the only two computers that you can see on your network, you're broadcasting. You're talking at a party. The louder you talk, the more people can hear your conversation. Talk loud enough and everyone at the party knows about that wicked case of diarrhea you have. So again, with broadcast networks, every piece of data goes to every computer, regardless of what computer it was supposed to go to. And this is literally like terrestrial radio and TV, which is why I'm using the RKO radio picture GIF. If you have 26 computers on a network, and computer A wants to send a file to computer B, computer C through Z will get every piece of data that computer B gets. They'll usually ignore it because that data is not meant for them, but they'll still get it. So this works okay if you have a small number of computers on a network. A few hundred, maybe even a few thousand. But what if you have billions? Before you discount this, let's just say, to make things easy, the US has a population of 300 million people and 90% of them have 2 computers, all on the internet. That's like 500 million computers. Now extend that out to all the other countries. Every person who can have a computer probably has 2. That's billions of computers all yelling about their diarrhea at the same time. And mind you, I'm only including stuff that actual humans control and use. I'm not including the even larger number of computers that you never really see or think of that are also on the internet. Like if you have a Tesla, your car. So what happens when you're trying to have all billions and billions of computers talking to each other at the same time? Well, there's a professional phrase for this. It's bad, very bad. So there are 2 ways to avoid this. They're fairly simple and they both work together, subnetting and routing. Yes, I know, switching. However, switching's primary use is not really the same as for subnetting, although there's a lot of overlap and it kind of all blurs together now. And you don't parse this out as much as you used to, but I'm just sticking with subnetting. Keep this simple. Technically, you can have subnetting without routing and vice versa. You don't see it a lot, doesn't make a lot of sense, and it really limits what you're doing, but you can do it, and there maybe are times when you'd want to. With subnetting, we add a number, a subnet mask that works with routers to say if a computer identifier address is in this group of numbers, its data only goes to other computers whose address is also in the same group of numbers. Think about it like if your address was between 0 and 100, you're going to talk to only the computers between 0 and 100. Computer 101 can't hear what you're saying at all. You don't exist to it, unless we have routers, which we'll get into in a minute. Now, if any of you work with Photoshop or any other image editor, then the way you use a mask in those apps is the same thing. It separates things so that the actions you apply to the unmasked part of an image aren't applied to the masked part. To go back to our party example, you realize, hey, I don't want everyone to know I got the runs. So I'm going to take my friend into another room and tell them there. I am not saying your friend is that interested in the state of your colon, but poop does get people's attention, so. Now, the network is still broadcast, but thanks to subnets, the size of the group of the computers getting the broadcast is much smaller. Instead of billions, it's 100 or so, maybe even less, often less. The way you speak hasn't changed. You're still talking. Anyone in range can hear you. We've just ensured that the number of people able to hear what you're saying is much smaller. That's all subnetting does. We're not changing how Ethernet or Wi-Fi networks work. We've just drastically reduced the number of computers capable of receiving the message. This becomes so much more manageable on every possible level. Security, bandwidth, almost every term you've ever heard of. I mean, you don't really need to be a sysadmin to get that managing 10 things or 100 things at once is way easier than managing a billion or more. If you need to talk to a computer in a different group or subnet, then the router handles making sure you can. That computer can be the next desk over, or it can be in space. And I'm not exaggerating here. The International Space Station and a lot of extraterrestrial satellites and probes use the same networking protocols as your computer, phone, fridge, whatever. Let's continue our party example. Let's assume that you don't actually open or close the door to the rooms in the house yourself. This party is at the rich kid's house, and every room has their own door person. So if you need to talk to someone in the other room, the person in control of the door opens the door, and now you can talk to a person in the other room. If the person is many rooms away, because this is a big-ass house, all the door people have this quick convo and figured out the smallest number of doors that can be opened to do this, or the best route. See there? Router? Right. Since these are computers and not people, this happens really fast. Instead of door people, we call the device that manages this routers. Also note that the best route in terms of speed may not be the shortest route in terms of distance. If you ever watch where packets go on the internet, where data goes on the internet, it can go some pretty weird places to go a couple of 100 miles. The data itself might go a couple thousand miles, but it's faster than going in a straight line. There's a lot of reasons for that, none of which I'm going to get into. At least not this episode. That's the concept of subnetting. It keeps everything from talking to everything else at the same time. The specific details are a little bit more complex, but we're not going to talk about them today. But yeah, this is really that simple. I've actually, in terms of the concept of subnetting, I've over-explained here, and rather a lot, but that's literally all subnetting does. It is there to keep everything from talking to everything else at the same time. That's it. Thanks for watching, listening, whatever. Later.